Hi, I'm Dan Stanzione. I'm the Associate Vice President for Research here at the University of Texas at Austin, and I'm the Director of the Texas Advanced Computing Center. So TAC, or the Texas Advanced Computing Center, we're both the UT Austin High Performance Computing and Research Computing Center. We're also sort of a central resource for UT System, and perhaps more importantly, or at least at a bigger scale, we're the leadership class computing facility for the National Science Foundation, supporting open academic research all around the country. I think inference is going to play a steadily more significant role. Historically, a lot of what we've seen has been more on the training side, but as these foundation models mature, or even just integration of large language models as research assistants and things like that, we're expecting to have a really rapid growth in the number of always-on models that we're going to need to have that can be inferenced either by humans interacting with them in the sort of chatbot method, or increasingly programmatically, right, through APIs, where actual other applications running on the big systems will be calling these models to get an inference result. So I would say most of our usage has been on the training side, but I think it's starting to pivot to where we're going to see sort of equal usage on the inference side as these steadily better models get released and pushed out to the scientific community, and then the utility of them is to have them on and available. So I think our inference workload is probably going to be our fastest growing AI workload in the next few years. The driver in our interest in SambaNova has been the ability to host many models simultaneously and to be able to quickly switch between models we're hosting by just extending the storage out to do this fast inferencing type work. You could have sort of a purpose-built platform for doing inferencing, and you think that's going to be an essential part of our ecosystem moving forward. We're installing the SN40L servers from SambaNova. I think each of those systems ought to be able to host, roughly speaking, about 1 trillion parameters worth of models. And again, the biggest large language models are pushing 1 trillion parameters, but a lot of the scientific models we're going to see are much smaller, maybe a few billion parameters. So we think we'll have capacity to host maybe up to 200 simultaneous models that are running and always on, whether it's chatbots for instruction or interactive use, or scientific foundation models for sort of automated use. We think we'll have enough hardware to scale to hundreds of models with this first set of SN40Ls we're deploying now. I think the first use case we're going to see is we're already getting sort of peppered with requests for chatbot type things. And some of those we can provision through the cloud or through other services, but increasingly it's like, yes, but I want to tune it to my data, or I want to use proprietary data or healthcare data from the med schools, or other things that make it harder for us to deploy that as a remote service, where we really need an in-house platform. And so I think our first use case will be when people come to us and say, I want to host yet another custom-tuned chatbot, it's a fast path to yes. Universal truth in sort of outsourcing these kinds of things is, if you use it occasionally, it makes a lot of sense to do it at somebody else's site. If you use it all the time, it's always more cost-effective to have it your own dedicated on-premise thing. And that means, just from an economics perspective, the most sensible thing is to have an on-premise one. The other one is just increasingly the sensitivity around the data that goes into these, right? If we're using, we have people who want to do things like build AI models of student application data to see where we're most effective getting students or not getting students. And obviously tons of privacy concerns around that kind of data. Again, there's so many uses in healthcare where we may not have completely de-identified patient data, so you wouldn't want to put those in sort of models that you're randomly accessing from another site over the internet. Although there are effective ways to do all that through cloud services, there's a certain comfort level with having your data reside physically within the walls of your campus that we see from a lot of our users and clients. So I think there's a huge comfort level with us being able to say, yes, here it is, it's in this rack, it's on premise, this is how we control it. If you want to make people feel good about your data protection and assurances and a private model that you want to have, this is the best way to do it. Power efficiency is super important to us at this point. This is something that this platform is great at versus having just sort of dedicated GPU nodes for each model. In our next generation data center that we're constructing now for our big supercomputing and large scale training systems, we're building out another 15 megawatts of capacity. It's going to take us to 25 megawatts. We're starting to look at $12 to $15 million a year just for our electric bill around here. And so this is a much better solution for us on the inferencing side in terms of the amount of hardware power we have to throw at it we are building a new data center because we ran out of power in the current one. So yeah, power is a very big concern that I think drives all of our hardware and increasingly software decisions moving forward.